So I will introduce about our project. Our project is to make the AI driven car inside a 3D simulated environment. This problem that we need to solve is the vehicle should react in real time to have a fast decision making, which is to react within a 50 milliseconds and a reliable control response. So if the vehicle fail to react within the time, it will maybe will cause a red token collision, which will decrease the speed, or just a collision with the police car, which will cause the game over effect. And then if it doesn't have a reliable control response, it will cause the wrong lane switching or twitching between a lot of lanes, and also will cause event failure as example like the golden lane event. So this is our system architecture, which we will connect the front camera and back camera of the vehicle, and then both camera will capture the image as a frame and send to the perception task. In the perception task module, it will detect the lens by detecting the white line, detect the color of the tokens on the routes, and detect the events. The events we have is at first is darkness, which the light will dim down and then the color will disappear. The vehicle will need to reverse for to remove this effect, and also police car events, which the car needs to take at least one red token or and also avoid collision with the police car, and chasing car event and to avoid chasing car, and also golden lane event, which is to stay on a lane for 5 seconds. And then after it proceeds to detect the event, detect the lens, and detect the color of token, it will save at the mutex shared memory, which mutex will help to log the data since a lot of tasks will use the same data. This is to prevent racing between the data between the tasks. And then next, the decision task uh, will take the shared memory data, and will based on that it will use a business logic, which we will discuss later, to select an actions for it, and then it will send the action to executions task, which it will control the vehicle executions, steering, braking, or other. And then at the end, after actuation task proceed, the racing vehicle will react for it.
The managed portion, this slide shows the system the seed road for the line. For then we convert this magic from the RGB to the HSV color, which is a handle the brightness changed better. We close the row area to detect the line using the white and the through holding for the tokens, reading three colors, green for rewards, and red for the penalty, yellow the random effect, and filter is by side ignores noise. For event, the darkness is directed by overall brightness and golden the light by the finding the greeting line. One can choose uh, we we disable the policy and charging the car detector because at night the blue sky and our owner record will cause the false alert. About the 16.7 first adoption in the 15 second. So we choose the sensor level Q instant. This is a delay level is run fast, and to meet the millisecond deadline is using by priority level. First darkness override top priority because it's dark screen to hide everything else, so we through the break clear E. The second place event is a crash that enter the game. Avoidance comes first. Third is golden light and crushing the avoidance golden light first for speed. The crushing avoidance to prevent the speed loss. Last, no more best driving the penalty for the reward for grid and the stability cause the way too much length switching, avoiding the matter to more than the crushing grid. This slide is the RTO's implementation. Final is the RTOS setup. For text work together, the camera receives the front and the position analysis. Then decision is made the command the actuation to control the car. They run on the fixed cycle and share the data through the shared memory. A mutual protect is so the text never crash. Each update replay the full state at twice. So every the read is consistent. Everything is must finish. We need the 15 millisecond. So that is hard to deadline. This is why we meet to the RTOS is keep telling the predictable.
Next, I will present the experimental result of our system. The self-driving car was able to successfully complete most of the important events, including the darkness event, golden lane event, and encasing event. However, the police event was still challenging because it requires faster and more accurate detection and reaction. In terms of performance, the car achieved about 28,000 meters within 180 seconds. One of the main limitations we observed was the red token problem. A red token, a red token decreased the car speed by 20%, while a green token only increased the speed by 10%. Therefore, avoiding red token is more important than collecting green tokens in order to maintain overall performance. In conclusion, we successfully developed an RTOS-based self-driving architecture for a simulated engine environment. The system integrates computer vision, partition, multi-based shared memory, and a hybrid decision-making strategy to enable real-time autonomous driving. Despite the successful implementation, there are still some limitations, especially in night sim partition and the decision of the police and catching events. For the future work, we plan to improve the object detection module, explore learning-based partition and partition techniques, and develop more intelligent event handling strategy to increase system reliability and performance. That concluded our presentation. Thank you.